So some of you have asked me to give you some assistance with loops, the material that's in chapter 6. And so remember that when we were writing programs in the past, if we needed to repeat lines of code, for example, if I wanted to simulate rolling a die over and over, if I wanted to do that, I of course would set up my random number generator, and then I would say die.nextInt, and I would put a 6 in here, and then I have to put +1 because otherwise I get 0 to 5. And so if I wanted to simulate rolling that die 10 times, I would literally, and then of course I would have to put in a print line so I could see it, right? Could see the output. So if I want to simulate rolling this die 10 times, I have to copy it, paste it, paste it, paste it, paste it, and on and on and on. Imagine if I wanted to simulate 100 times. That would be a lot of copying and pasting. And then what if I realized I made a mistake somewhere in here? What if I had left out the +1 on all of these and I realized, oh no, I've got to go back and I've got to add +1 to all of them, and hopefully copy and replace helps me with that, but I could still make a mistake and maybe I catch 98 of them and I forget to fix 2 of them, and then I've got kind of a logic error situation going on. So the copy paste is prone to error. So thankfully we don't have to do that. We can actually write a loop that will repeat the code for us. So we can write it one time, stick it in a loop, and then tell the loop to run 100 times and do the simulation for us. Now we have a couple of options. There are 3 types of loops. There is a do-while loop, which is covered in the textbook. That is not on the AP exam, so we're not going to worry about that, but it always executes at least once regardless, and then it decides if it's going to continue on. So it executes one to many times. But we're not going to worry about that one. The 2 that are left are the for loop and the while loop. Now, when we sort of have an idea that yes, we want this loop to execute X number of times, we may not know what X is, but we have a pretty good idea that we want it to execute a certain number of times, we'll tend to use a for loop. We'll also see a good use for a for loop in Chapter 7 with arrays. When we're not quite sure, do we want it to execute at all? Do we want it to execute how many times? We'll tend to use a while loop. Now a for loop executes 0 to many times, a while loop executes 0 to many times. But the for loop, if you really look at it, it's really sort of designed almost like you know that you want the thing to execute a certain number of times, whereas a while loop is used a lot more when you're not sure you ever want the loop to fire off. And they're pretty much interchangeable. You can write them either way. You can write something with a while loop, you can also write it with a for loop and vice versa. So if I wanted to simulate rolling the die a certain number of times, and say I wanted to simulate rolling the die a random number of times. Sometimes I run this program, I want it to run it 10 times, 12 times, 50 times, 100 times. I want to do different simulations. I could say I could set up, a random number generator. And let's say I want to have it randomly roll the die anywhere from 1 to 100 times, okay? So I can control that with one random number. Here is my roll that I've set up, and here is the code that I want to repeat to simulate rolling the die multiple times. Well, I can use a for loop. and I'll talk about the setup on this for a minute, but I can put this code in a for loop, and now it will execute a certain number of times. So if I want to simulate 10 rolls, I could put a 10 here, I could put 100 here, I could put 27 here. I can simulate how many rolls I want. Now I said I was going to have it roll a random number of times, so I'm going to generate a random number between 1 to 100, and say I get back the number 50, this is going to execute 50 times, okay, and so on. Actually, let me start the counter with 1. So here is the basic setup for a for loop. So the body of the for loop is in between the two braces here, and the body is the code that you want to execute over and over and over. So I want it to roll the die. Oops, I want it to be a 6-sided die from 1 to 6, and then I want it to print it out. Now, the tricky part here is the setup on the actual for loop itself. So I have to establish a loop counter variable that helps me determine, sometimes it'll tell me the number of times the loop is executed, but it will always help me stop the loop so that it doesn't become infinite and crash my computer. So the loop counter is critical. It will help me stop the loop at the appropriate time, and sometimes it will tell me the exact number of times the loop executed if I need that information. Not always, as we'll see when we deal with other loops, but sometimes. So I have to set that counter up, and that is always the first part of what is in the parentheses for the for loop setup. I declare and initialize the counter variable here because I only want to use the counter variable in the loop, and then I want it to be destroyed to free up the memory to be efficient. So I want it to be created only if and when the for loop runs, and I want it destroyed when the for loop stops running. So its scope or its life or its visibility is only within the braces of the for loop. I cannot come down outside of the for loop and try to print out that loop counter variable, because I'm going to get a compile error saying I don't know the variable I. And you're going to say, yes, it's declared right here. What do you mean you don't know it? By the time this last line of code in the for loop executes for the last time and execution comes here to this print line, I has been destroyed. It's actually been wiped out of memory. The computer doesn't even know it existed. So you cannot reference that variable outside of the for loop. It lives and dies in the for loop. So you usually will see people starting the variables with 0. That is particularly important when we get to chapter 7, but there are times when you'll want to start it with another number. So here it makes a lot of sense to start counting with 1, just like we do in real life. And if my number is 50, I'll go 1, 2, 3, 4 up to 50. As long as I is less than or equal to 50, I will run the loop. When I gets to 51, that will be greater than 50, and I will stop, assuming that how many is 50. Now the second part is a Boolean expression, and this is critical. It determines when the loop executes and when the loop stops, so it doesn't become infinite. So here I'm generally, most of the time, comparing the loop counter variable to some other numeric value. And as long as this condition evaluates to true, the loop runs. The second this condition becomes false, the loop stops. It does not execute again. And that is important. That's what keeps it from becoming infinite. So in this case, I want this thing to loop as long as the value in I is less than or equal to that random number how many that's been generated. So if I say my random number how many is 5, I starts at 1, it'll go 1, 2, 3, 4, 5. The loop will run 5 times, and as soon as how many gets to 6, as soon as I gets to 6, 6 less than or equal to 5 is a false statement, and the loop will stop. And here is also another part, and the parts must be declared in this order. You must declare and initialize the counter variable, Then you must do the Boolean expression that controls when the loop runs and when it stops. And then you must do something to control that counter variable to increment or decrement it so that, again, eventually this condition becomes false and the loop stops. So here what I'm saying with I++ is every time this loop runs, I want I to be bumped up by 1. So I will go from 1 to 2 to 3 to 4 to 5 and so on. So I++ is shorthand for saying I equals I plus 1. So you can put that, you can put I++, or you can use the other shorthand notation I equals I plus 1. All of those mean the same thing. They mean take I, and every time this thing loops, add 1 to it, so we can make sure that the counter eventually gets to the point where the loop condition here will evaluate to false and the loop will stop. So now let's think about this for a minute. I'm not really using I'm not using the counter variable here. I'm not doing anything with it. I'm simply letting it control when the loop runs and when it stops. So here's what happens. If I wanted to, I could print out the value of I just to show you how I is going to work. But basically what happens is I is going to be 1 before the loop ever runs. I is set to 1. And how many has been determined already by the random number generator. Let's say it's a 5. Before the loop ever executes, this condition is checked. Is the value in I, which is 1, less than or equal to 5, which is the value in how many? Is 1 less than or equal to 5 a true statement? Yes. 1 is, in fact, less than or equal to 5. That is true. So the loop will execute the first time and it will print out the die roll. Now, at the end of this last line of code here, the loop will take the value in I, which is 1, and it will then add 1 to it. So I will become 2 at that point. Then it will reevaluate. Is 2 less than or equal to 5? Is that a true statement? Yes. So now it will loop again with I being 2, and it will print out the next die roll. So I will be 2, the roll will print out. Then, before anything else happens, 1 will be added to 2, it will become 3. The condition will be checked again. 3 is less than or equal to 5. It will keep running until eventually I becomes a 6 and the condition is no longer true. So my recording is going to run out of time here pretty quickly, but I wanted to show you how this is going to look when it runs. So let's go ahead and compile it. So I went back and added a little bit of output to make the output clearer, some print lines rather, how many rolls and then what the die roll and what the loop counter is, and I ran it. And so this time it's going to roll the die 19 times, comes in, it rolls a 4, the loop counter is a 1 at the end of the first run, and then it actually becomes a 2 pretty quickly, and 2 is less than or equal to 19, so the die is a 3, and the loop counter goes, as you can see, in order up till the loop counter is 19. At the end of that 19th roll, I becomes 20. 20 is not less than or equal to 19, which is the value in how many. So I is 20, how many is 19? That's a false statement. The loop stops at that point. So I'm hoping that this lecture has helped you understand, while we could set the for loop up to never execute, it is possible a for loop might never run, just like a while. Generally, for loops are used just for conditions like this, where maybe we're trying to simulate something happening X number of times, like a die roll, a coin flip, something along those lines. And we'll also see a perfect use for for loops when we deal with arrays in Chapter 7.